or anyway, these two are parallel. We can replace, no doubt. Okay, only six loops are there. These two are parallel. We can do, but you can't say these two are parallel. Huh? No way that one. So 1, 2, 3. So again, can you make these two parallel? Yes, it can be, no. There's a common. Okay, there's a 1, 2, 3, 4, 5. 5 loops, 5 loop equation. You'll be in a big trouble. Huh? No professor wanted to test your mathematical skills in physics. What is it? That loop method is all. Shall we go for branch current? Shall we assume current I1, I2, then I3? I think it'll take 1 hour. Huh? So loop current is available, not possible. Branch current, not possible. Then grouping of cells. There's a cell. Okay, these two, there's a one cell. Effective what happen? This will be one cell. There's a one cell. These two again effective one cell. Okay, to some extent you can solve grouping of cells, but every time not advisable grouping of cells. Okay, there's a third approach. Fine. Okay, now loop current method, branch current method, grouping of cells. 3 standard ideas what we know. All 3 are lengthy. Nodal analysis, you can do this in very simple way. Within 2-3 steps, you'll get answer. But so many things are there. Okay, try to think now. So whose help you should take directly come for this particular thing. 20 volt is there. We have 10 volt. Again, we have 20. So how to write? We have to define for nodal analysis, what is the biggest problem? We should define the potential at various junctions. How many junctions are there? 1, 2, 3, 4. Okay, 5. There's also junction 6, 7, 8, or at all. We should define the potential of this edge and this edge. As this is a uniform wire, the potential should be same. Conductor is an equipotential. So shall I begin like this? There's a potential at this point, plus 10 volt. I'll take help of a cell. Then everywhere potential should be same. If this is minus 10, shall I write? I'll remove V because writing again. No. There's a minus 10. What can be potential? Potential difference should be 4, no? So shall we write minus 6, this one? Minus 6 minus of minus 10 will be plus 4. This should be minus 6. This should be minus 6. And this is plus 10. This should be 0. This should be minus 10. Minus 10. No, this should be plus 10. And we don't know this. I'll call X. I think I really. But what about here? How to define this one? So here 10 you wrote. If you want, you write minus 10 here. But anyway, not needed. Okay, this will be minus 6 is there. Okay, keep it here. So I'll focus on this particular junction. Current here, from here, current in these two branches will enter and it will leave, let's assume. So current entering a junction should be equal to leaving junction. So 10 minus x by 4, 10 minus x by 4 should be equal to x minus of minus 6 by 2. At x, 10 minus x by 4. No. Anybody value X? 2. Okay, once you know X, then you can calculate current, right? How much?
2, sir, current
2
also.
only, 2 only. Yeah, 10 minus 2 by 4. No other way, no. For us, you only see, so nodal analysis will really help us a lot. Especially the circuit is very big, no. The nodal analysis is only alternative. I think what you have to do is like, sir, how do you come to know current entering or leaving? There's another question what you can ask. So what is the here current entering living? I took it, but at some places we don't know current entering or living. To be frank, here he has shown direction of I. Okay, we thought it. So in that case, so what should be your thinking? Your thinking should be algebraic sum of currents at a junction should be 0. So x plus x minus of minus 6 by 2, x minus 10 by 4. I think this is what I suggested you. Can you remember? We don't know current where algebraic so from junction you write it. This is not advisable. Please do follow teacher instruction to make you understand, since I brought it, but this is the general thinking. I think this is advisable. So sir, how do you come, how you can say current year entering, current may flow? So that's a very good question what you can. So therefore what I suggest, at this particular, at a junction you write it x minus of minus 6 by 2, x minus 10 by 4, x minus 10 by 4. We don't know where current entering or leaving. Solve it. The potential at x will get, from potential of x you can say where current is entering or leaving. This is advisable. Huh?